So hello everyone, I'm going to be talking to you about Dave and I's project. Hello Dave, by the way. Hello James. Hi Nick. Hey classmates of IFB 102. So I'm going to give you a quick run through of what exactly we did in our project by looking at first the schematic view. We were doing a Twitter bot, and so we wanted one Raspberry Pi to interact with Twitter and to send that information to another Raspberry Pi over here, and then have that Raspberry Pi host that information pretty much on an Apache web server, so that we could have a look at what was happening, and so everyone else could as well. I wrote two programs here, tweet.py, which took information from the Twitter space and passed it off into a text file, pretty much no formatted text file, which was absolutely disgusting. I'll show you in a minute what it looks like. And moved it into Twitter analysis, which then passed the data, so gave the data some structure and visualized the data, and then moved those visualizations, those portable network graphics, to a directory up here, which then synced with the directory of the second Raspberry Pi using this remote sync algorithm and an SSH security protocol. So there was an exchange of public keys between these two Raspberry Pis, just so Nick couldn't hack our network pretty much, but I'm sure he still can because he's sneaky, super sneaky. Okay, so the directory image was then synced locally within the machine, the second Raspberry Pi, to the Apache 2 web server, and then hosted on the Pi's local IP, the IP address, yeah. And this was all timed through a bash script down here. So let's have a look at what some of those programs did and how they interact with each other. So this is the one that we want to look at. This is the tweet miner, so the tweet.py program. And it pretty much just uses this tweetp package to listen to tweets, handle the authorizations, and also handle the stream filters. So a stream filter is just a keyword that I want to filter from the Twitter sphere, if that's the correct word. So I put in all of my access tokens and authorization tokens and consumer keys up here. So I've just created an account with Twitter, and they allow me to run applications on that account, and I need some authorization, and these are those authorizations. So I say print the data if it's there, print me the error if an error occurs, pretty much. So let's have a quick look at the output of that. So here we have Python tweet.py. And you can see it's just this absolutely disgusting data. Oh, notification. Disgusting data that we can't deal with alone, so we have to give it some structure. But right now, I'll just pipe it straight into this twitterdata.txt so we can have a look at it in a second. And this is exactly what the bash script does. It pipes it straight into a text file. And then we move on to our next program, which is the parser, the Twitter analysis. So it parses the data, it gives the data structure, it visualizes the data. So that's exactly what this is doing. It takes that Twitter data file and it puts it into arrays, and then I'll use some control statements on those arrays to create this CSV file. And then I output that CSV file so I can have a look at it, and then I pretty much start constructing visualizations with that structured data. And I output each of these visualizations as a PNG file, portable network graphic. As you can see, output here into directories. This regular expressions is just a fancy way of saying keywords, as I said before. So I'm looking at Trump, Clinton, and Sanders. And all of these are just a count of how many times these events occurred, pretty much. And I then output it again. So now we can stop running that. And we can run the Twitter analysis right here. And if you want to have a look down here, so this directory is completely empty. I run Twitter analysis, and then there we go. We have these three figures here, which are then moved to the second Pi. Alright, so in the second part of our project, we were looking at the inner workings of the second Raspberry Pi. And so what we were doing was using this rsync algorithm to go from the first Raspberry Pi's directory image to the second Raspberry Pi's directory image, and then using rsync again locally in the Raspberry Pi 2 machine to move it down to where the Apache 2 server would host those images. So if we just pull up, this is acting as our first Raspberry Pi, and this is the second Raspberry Pi here. We just have to run this rsync program right here, and it's going to take these images from this images directory and put it into the images of the pies directory, as you see here, images right here. Something to note is that we're actually not in this image directory, we're in a different image directory in the directory of the Apache 2 web server. So if you have a look here, I'll run this, which is exactly what our bash script does. So it runs this exact piece of code here. And then the rsync inside this Pi has straight away added these straight to our image directory. And so this was our hosted HTML just before the images were added. And now that they are added, you can see that the graph of the top 5 languages, of the top 5 countries, and the frequency of Trump, Clinton, and Sanders, which were regular expressions, are all displayed on this final HTML output. Okay, that's the end of our project. Thank you very much.